are all the aliens. So you've probably got some ideas of what an alien looks like, but we'll come to that later. First of all, let's have a vote on whether aliens exist. So give us a cheer if you think there are aliens out there. Yeah. Give us a cheer if you think there aren't.
I think that's a win for there being aliens.
Yeah, sounds like it. Oh well, we'll see how that's changed by the end. Okay. Now space is really big, really, really big. Does anyone know the fastest thing in the universe? Okay, let's go with you in the blue t-shirt. Light. Very good. You got there straight away. Does anyone know how fast light is?
300 meters per second.
Very good.
Wow, they're good, aren't they?
Yes, that's exactly the point I was coming to. So we've got some examples of things for comparisons with the speed of light. So Usain Bolt, fastest man, runs at 12 meters per second, which seems pretty fast. But a car goes at 31 meters per second, a cheetah at 33. The Thrust SSC is the fastest land vehicle that's ever been made, 341 meters per second. It's not quite as fast as the speed of sound, which must have been slightly annoying for them. But Concorde went way past the speed of sound, 606 meters per second. Space shuttles have to go really fast to be able to escape the Earth's gravity pull, and that's 7,800 meters per second. But as you correctly said, light goes at nearly 300 million meters per second. So, that means it can cross this room in about 60 million times in 1 second. The furthest bits of the universe are so far away that it would take light 47 billion years to get here. That's over 3 times longer than the age of the universe. So yeah, there's quite a lot of the universe for us to search through, and it takes a long time to do that. And we couldn't build a rocket big enough to take all of you out there, so we're not going to be able to do that in this talk. But however, with the latest technology and the best telescopes and some demos, we can bring bits of the universe to you right here.
So the easiest place to start in our search is in our own solar system. So at the centre of the solar system, we have the Sun, on the left here. And the Sun is surrounded by 8 planets, which all orbit round it in big circles. Lots of these planets have small objects that go around them, and we call these moons. And the Earth has just one moon, which you'll hopefully all have seen in the sky. But also lots of smaller things like asteroids, comets, and meteoroids. So first of all, we're going to look at the Earth, Moon, and Sun. So I'm going to need 3 volunteers. So we'll have you, your hand up quickly. We'll have you in the pink, and we'll have you there in the grey. So, we need 3 of you to act out being the Sun, the Earth, and the Moon. So, one person the Sun. So, what I need you to do is I need you to stand here and hold your hat on.
Your Earth hat on, there we go, and you can be the Moon.
So, hold the torch. Now, you are the Moon and you are the Earth. So, if you stand here, and the Earth, can you stand here? And the Moon, can you stand here? Okay, now can you point the torch at the Earth, being very careful not to shine it in anybody's eyes? And you switch it on like that? That's it, okay, good. So, can we all see that the light is shining from the Sun onto the Earth? This is how we see light. And we find that as we shine onto the Earth, one half of the Earth is lit up, which is on this side, and the other half isn't. So Earth, can you now spin around slowly on the spot? That's it, just a couple of times. So as you see, do it once more. As you can see, the bit that's being shone on changes. So when it's over here and it's light, this is daytime. When it's over here and it's dark, this is nighttime. So now we can do another thing. So Earth, can you walk around, and so the time it takes for that is 1 day, of course, to go between the night and day. So can you walk around the Sun once for me? So you'll notice that as the Earth goes around the Sun, this is the time actually that we call 1 year. It's the time for the Earth to go around the Sun. So where does the Moon come into this? Now the Moon goes around the Earth. Can you walk around the Earth for me? So stop there. So when the Moon is here, the light's all shining on the Moon. And so the side of the Moon that the Earth can see doesn't see any light on the Moon. So the Moon appears dark, and we call this a new Moon. Now if you go back to where you started, you see now the side of the Moon that the light is shining towards. Can you shine it on the Moon? It's facing towards the Earth. So if the Earth looks at the Moon, Earth look at the Moon, we can see a load of lights there, and so we see a full moon, a big moon in the sky. and in between we see other phases like crescents. And this takes about a month for the moon to go around the Earth. So, thank you to all of our volunteers. Give them a big round of applause.
Thank you very much. Brilliant. Thank you so much. Great. All right. So we've had a look at the sun and the moon and the Earth. But now, to start knowing and looking for aliens, we have to think a bit about what they'll be like. So on Earth, we've got all sorts of life. Of course, the cleverest species is humans, and we've got technology and language, and we can even travel into space. But there's lots and lots of animals as well, from mice up to elephants. And we've got plants, we've got fungi or mushrooms, we've got bacteria, germs. So we've got loads of different life just on Earth. So when we look for aliens, we can't just look for little green men. We've got to look for life of any sort. But what is life? You might have come across the acronym Mrs. Graham. It tells us the 7 things that all life does. So that's movement, respiration, which is breathing, sensitivity, so being able to feel things, see things, hear, look around, or touch, all those things. Then we have G for growth, so getting bigger. And then reproduction, that's making new plants or animals or bacteria, having babies. Excretion, so that's doing poos and wees. And finally, nutrition, so eating and drinking. Now these are the things that life has on Earth, and that's what we're looking for. And you'll probably think there's certain things that we need to be able to do these things. Can anyone have an idea of what things we need to be able to live? Yes, you? Air, very good. We need air to breathe. That means we need an atmosphere around the Earth. Yes. Food, very good. So we need to be able to have things we can eat. That means plants have got to be able to grow and stuff like that as well. Yes. Water, very good. Water to drink. And you in the green? Sorry? Yes, that's true as well. They're in the atmosphere too. And so we've got all these different things. We need air to breathe, we need water. So to find aliens, we've got to try and find these things.
So we then can say, well, let's look around our solar system, which we introduced a minute ago, and see if anywhere has these things. So we can start at the moon, because the moon is the only other place than Earth that we've actually visited. The Apollo astronauts about 50 years ago now. But they didn't find any aliens, and they brought back lots of stuff we could test to see if there were any signs of aliens, which there weren't. So we can be pretty sure there isn't life. And the fact is, there's no atmosphere, and there's no liquid water, so it'd be pretty unlikely anyway. Although I say there's no liquid water, but these dark patches are actually called seas, and that's because originally people thought they were water, but we now know they're just made of dark volcanic rock. So the moon's not a very good place. What about the sun in the centre? Well, the sun is this big ball of gas, and it's millions of degrees, so it's not going to be a very nice place to live either. The actual sun is about 1 billion times bigger than you see on this board, and we're going to use this scale to actually compare the sizes of the planets as well as we go along. But it's definitely not somewhere to look for aliens. So, the closest planet to the sun is called Mercury. It's also the smallest. If the sun were this scale, as seen on the board, Mercury would be this scale, as shown here. So as you can see, it's a lot smaller. It would also, on this same scale, be about 80 metres away, well outside the lecture theatre. It's quite similar to the moon because there's lots of craters and there's no atmosphere. But because it's so close to the sun, it gets very hot in the daytime, over 400 degrees C. But at night time, it's minus 200, which is a bit cold. So definitely not a very nice place for aliens to live. Next up, we have Venus. Now, Venus is a little bit smaller than the Earth. And sometimes people call it Earth's twin. So you might think, oh, that's a good place to look, because it's a similar size and it's got an atmosphere. But the problem with Venus's atmosphere is it contains a lot of carbon dioxide. Who's heard of carbon dioxide? Yeah, lots of hands. So carbon dioxide is a big problem on Earth because it's what causes global warming, because there's something called the greenhouse effect. Now, if you've been in a greenhouse, you've probably noticed it gets quite hot in there, and that's because it traps the heat, and the carbon dioxide does exactly the same thing. The CO2 acts like glass. So Venus is over 450 degrees C. Again, not a very nice place for aliens to live. Now, the next planet out from the sun is the Earth. I mean, this is where we are, so I don't think it's going to be too difficult for us to look for life. What do you think? No? Okay. But the good thing about the Earth is we have an atmosphere and we have liquid water. And this is because we often say the Earth is in the Goldilocks zone. it's not too close to the sun and therefore too hot, but nor is it too far and too cold. But we'll talk a bit more about that later. So then the fourth planet is Mars. It's smaller than Venus or Earth, and it's often known as the red planet because it contains the same chemicals as in rust, which give it this colour. And again, on this scale, it's pretty small. It's quite difficult probably for you to see that. It does have an atmosphere, but it's very thin. And because Mars is much smaller, it's cooled down more quickly, and the average temperature is below 0. So I'm going to set up an experiment we'll come back to in a minute as to why this is, and pour some warm water into these two beakers I have here on the desk. So at the moment, as I set this up, the thermometers are still measuring the temperature, but this water is somewhere around 70 degrees C, so pretty hot, so not very comfortable at the moment. But we'll see what's happened after 5 minutes to the water in these two beakers. They're both at the same temperature because I poured them both in the same kettle. But any water now on the planet Mars is actually just ice. The steam has been blown away, and any liquid water we can't see directly. We actually basically see sweat patches on Mars, which is a bit icky. But in the 1800s, people did think they might be canals, and an astronomer named Schiaparelli drew this map of all these canals. And people thought, well, there must be some Martians building them. But actually, it's discovered they're a trick of the light. And so far, we've sent lots of spacecraft, but we've not yet discovered even any bacteria, let alone intelligent canal-building Martians. So this brings us on to the biggest planet, which is called Jupiter. It's actually made out of gas rather than rock. And there's these bands of clouds that you can see. And there's a big storm which is bigger than the Earth, and called the Great Red Spot. Now, since it's pretty much gas, and the gravity in there is so strong that the air is very heavy and would crush you. Again, not a good place to live. But the interesting thing about Jupiter is it has lots of icy moons that go around it. Remember, just like we have one moon that goes around us, other planets have lots more. And some of them, it's thought there could be liquid water beneath the icy surface. Now you might wonder, how is this possible if they're much further out than Mars, and Mars was too far and too cold? And the fact is that the gravity pushes and pulls on the moons. So take your hands and rub them together, and you'll notice that pretty quickly they get quite warm. And this is because of friction, you see? And the friction on your hands, when your hands push and pull against one another, heats them up. And just the same thing with Jupiter and the other moons pushing and pulling on each other means that they can heat up below the surface. And so there could be liquid water under the surface of moons such as Europa. And then the next planet out is Saturn. Now Saturn has this impressive set of rings. And again, on this scale, it'd be about this big, so probably much easier for you to see. It's quite big. It's a little bit smaller than Jupiter. Like Jupiter, it's made out of gas and so uninhabitable. But it also has lots of moons, which could also have seas under the surface. So again, people are quite interested in Saturn's moons. There's maybe somewhere we could look. But we haven't found any life yet. Now, the second to last planet is quite a bland-looking one. This is Uranus. It's another gas planet, but it's much colder than Jupiter or Saturn. And along with Neptune, the furthest planet away, they're known as the ice giants. And they're made of slightly different gases to Jupiter and Saturn, but they're still not good places to live. And on this scale, with Neptune this size and the Sun this size, Neptune would be something like 4 miles away, so well outside of Cambridge. Neptune, interestingly, has the fastest winds in the solar system. So I think we come back to Mars to see what the experiment I set up might be able to tell us, having left it for a couple of minutes. So what I'm going to do is going to be volunteer astronaut. Now, you know, your hand in the, no? But your hand goes up very quickly so you can come and help. So what we have here is we have 2 thermometers in these beakers to measure temperature. So this is going to let us see the difference between Mars and another planet like Earth. Now, do either of you know how to use a thermometer? Have you used one before?
Well,
Yeah. Okay, let's say you want to measure your own body temperature, but you want to measure this, so licking them is not going to be much use. So instead you need to leave it in these beakers and you need to come and look. So do you come first? You can see this one. Can you see this green line? You need to look at where the top of the green line is. Yeah. Yeah, and then read the number on this side. So it's just about 70 degrees C. So it's not really cooled down since I poured it in. Now can you come and read this one? Can you see this side? There's 60, so what number is that? 62. So by putting it, thank you very much, you can go back now, thank you. So the big one was at 70 degrees C still, but the little one had already cooled down by about 8 degrees. And so the difference here is that with the little one, more of the water is near to the surface, so it can all get rid of its heat much easier. And on Mars, this means that the temperature's gone down a lot more. And so it means it's lost what's called its magnetic field. It's like an impressive shield that shields it from a solar wind from the sun that blows away its atmosphere. So this is why Mars isn't habitable. So we've not really found anywhere yet that we know of life in the solar system.
So, we've looked in the solar system, haven't found anything yet, so we've got to look elsewhere. Now, to look for aliens, we've got to look for planets where they might be living. And it's comparatively easy to find out about planets in the solar system, because even though they're a long way away, they're much nearer to us than all the other stars are. It's nearly 3 billion miles to Neptune, but the nearest star is 25 trillion miles away. So, we've got to find some ways of looking for planets that we can't see properly through the telescope. Now, planets going around our stars are called exoplanets. And as well as being so far away, they're also next to really bright stars. So if you ever walk down the street and seen a car's headlights coming towards you, they look something like this. Basically, it's the same reason for exoplanets. You have to block out the light from the star to try and see the faint planets next to it. And astronomers have found 44 planets by doing this, but it's quite tricky to do, so we look for them using other ways. So another way is to look very, very carefully at the star that the planet's going around. So the planet goes around the star because the gravity attracts it to the star. But gravity works both ways, so the star's attracted to the planet. And this means that when the planet moves in a circle, it makes the star move in a circle too. But because the star's so much bigger, it only moves a little bit. So we're going to have a demonstration now. Andrew here is a star, and he's got a planet, and he's going to go round and round. So the planet's going around the star. Can you see that Andrew has to wobble around a bit to go around with the planet himself? So the stars and planets go around them wobble, and if we can look at the wobble, we can find out about the planet. One way of measuring it is to do something called astrometry, which is where you look very carefully at the star and try and see it wobble. But that's quite tricky. So instead, use something called the Doppler effect. So what is the Doppler effect? Have you ever had an ambulance come towards you and you hear it go like and then it goes past you, it goes down again. Basically, what's happening is that the sound coming out of the ambulance is being squished up, and when it gets squished up, it gets higher. And then when the ambulance is travelling away from you, the sound gets stretched out because the ambulance is moving away from you as it's making the sound, like you can see in this picture. And when it gets stretched out, then it sounds lower. That's called the Doppler effect. And the same thing happens with light. Light is also a wave, so it can be stretched and squished. When the light's more stretched out, then it looks more red. When it's more squished up, it looks blue. So if we're looking at a wobbling star, when it wobbles away from us, it'll look more red. When it wobbles away from us, it'll look blue. And the shift is really small. We can't see it with our eyes, but using special equipment, we can measure it and find out how much planet is making the star wobble. So astronomers have used that to find about 620 planets. But the most successful way of finding planets is using transits. So a transit is when a planet moves in front of a star, blocking out some of its light. We see Mercury and Venus orbiting sometimes, and you can see that little dot on the sun there. That is Venus moving in front of the star. So you can see a little dot there at the top. Now, of course, with planets around other stars, they're so far away, you can't see the planets themselves. You can certainly see that the star gets a little bit dimmer because some of its lights come down. Now, I have a little demonstration here. So, got a screen here. This is our star, and this is our planet. And so I'm now going to move the planet in front of the star, and you will be able to see that the planet's there. It passes in front of the star, and it blocks out some of the star's light. So that's what's happening with the transit. Now, if we have a different sized planet, then it will block out more of the light. So it'll easier, which means a lot of the transit planets we've found have been the big ones that are really near to the star, and it's hard to find small ones further away. The other problem is that not all transiting planets, we can't see all of them, because some planets will go around the star at a different angle, and they'll never go in front of the star from where they're looking. So we just never see them. So that's a problem. However, we've still found loads and loads of transiting planets doing this. So that's the place to end.
So I mentioned the Goldilocks zone earlier, because we found some planets and we're looking for aliens. So we need to know if the planet could actually have aliens on it, if they'd be happy there. So if you remember some of the things we said earlier, we had water, we had an atmosphere and things. So we need to look at these. And we'll focus on the sort of water, because if it's too hot, we'll get steam. If it's too cold, we'll get ice. So planets for aliens to live on need to be in what we call the Goldilocks zone. So this here shows us the Goldilocks zone, and how far away it is from the star, against the sort of size of the star. So you see the big ones here, it's far away, and the small ones here, it's much closer. And that's because the small stars aren't as hot. So if you imagine you had a small candle or a fireplace, you can get quite close without burning yourself. Whereas if you've ever been to a big bonfire night or something, you'll know it's much, much hotter. You've got to stand a long way away from it to be comfortable. So the Goldilocks zone is just further away from really hot stars. We also need to see if the atmosphere has the right things in it. Because, for example, we need oxygen to breathe in, and we breathe out carbon dioxide. So any atmosphere that has oxygen and carbon dioxide will look quite good. We'd also quite like to see some water vapour, because that means we've got weather, clouds going on. So when we have transits, we can actually look at the planet's atmosphere, because the atmosphere also absorbs an extra amount of light and blocks out some of the colours. So you see, these are all the different colours, and this is how much light. And we've got these big dips here, and so you can see that we have some from water, and we have some from oxygen and carbon dioxide. Now this isn't unfortunately a real planet, but we could do this with planets now, and we can get this. So the way we do this is by using a spectrograph. So Lucy will demonstrate.
Alright, so basically, we've got the light from the star, it's come towards us, and we want to know what colours are missing because they've been absorbed by the gases in the atmosphere of the planet. How are we going to do that? We need to split up the colours of light from the star into all their separate colours, and then we can find out which ones are missing. So I've got here a laser pen, and you can see if I shine it, then just on if I shine two of them the same colour, and they're right on top of each other, then it's kind of hard to see. When they're right on top of each other, you can't split the colours up very easily. It's a little grid, and that's what a spectrograph is. When you shine light through a really tiny grid, then it splits up the light into what's called a diffraction pattern. So there we go. Now I'm shining it through the grid, you can see, hopefully, the laser pen, with the laser light is split up into lots of little dots. How does that help us? Well, different colours of light split up by different amounts by the same grid. So this is the green one. You can see the dots are all quite close together. And then this is the red one. They're a little bit further apart. So that's what we do to be able to split up the light and find out which colours are missing and so what gases there must be in the atmosphere. Great. Okay, so this brings, we've gone through all the steps we need to look for aliens. We've found planets, we've had a look at what gases there are, but there was not very many aliens out there. A scientist called Frank Drake thought about this and came up with an equation to work out how many alien civilizations there are that we can communicate with. So first up, we need to know how many stars there are out there, and there's about 100 billion stars in our galaxy. But, okay, how many of those stars have planets, do we think? Let's have a guess. Does anyone have a guess? How many of the stars have planets? Yes, you can believe it.
Maybe like a 10.
A tenth? That sounds like a good guess. Alright, so we'll say a tenth of the stars have planets. Great. Okay, but only some of those planets are going to be in the Goldilocks zone so that they can have life. idea. All right. So about a fifth of those stars in the Goldilocks zone. But even if the planet's right for life, there might not be life living on it. So of the planets we've got, how many do we have life on them? You're in the red. 7? Perfect. All right, let's try that. Okay. But we need to be able to communicate with these planets, so we need to be intelligent enough. So you and the blue, what do you think? The ninth for the aliens to be intelligent enough? That sounds brilliant. Okay. Brilliant. All right, those are the last steps. So now, combining them all together, how many alien civilizations do you think there are?
So we get just under 32,000 alien civilizations in our galaxy that can communicate with us. What do you think?
Sounds good to me. So the thing is that the right answer? Is it not? The thing is, we don't actually know. Most of these numbers, we've got no idea what the real answer is. And so lots of people have had to go at guessing different numbers. And they've said maybe it's 0, maybe it's 156 million, or anywhere in between. So our answer's somewhere in between. So yeah, there might be that many out there. There might be loads and loads, or there might be none.
So astronomers are doing a lot of work to try and find out exactly how many planets there are, and exactly how many are in each solar system, and how many live in the habitable zone, and things. And then we can see how many actually got aliens. But one last question is, if there are 32,000 alien civilizations out there, where are they? So, surely some of them could have travelled and come to see us, but we haven't seen them. So this is called the Fermi paradox, after the scientists who made it up. Now people have come up with lots of reasons why we haven't seen aliens yet to get around this problem. Maybe there aren't any. Maybe they're too far away and they just haven't had time to get here. Maybe they're so different from us that we wouldn't recognise them, that we might be too narrow in our idea of what life is. Perhaps they don't want us to find them because they're scared of us. Does anybody have any more suggestions? Take a couple. Yes, you. They might not have technology yet. Perhaps we just haven't been looking for long enough for them to develop. Yes, in the white t-shirt. Yep.
Maybe it's
No? Don't know? What about in the bird over there? Yes, you. They're sorry, the what? They could be too small to see. Yeah, exactly. What's your favourite idea, Lucy?
My favourite idea is that actually the aliens are here, but they're just so sneaky that they're hiding from us and we haven't spotted them yet. So that's my favourite idea, but who knows?
So lots of people are looking for them, and there's a group called SETI, which stands for the Search for Extraterrestrial Intelligence. Extraterrestrial just meaning away from the Earth, so aliens basically. And they're listening out for any signals that the aliens might be sending us, because we've been sending them things. We've been sending them signals like our SEGRO telescope, and also we send them a lot of their TV, because all our TV signals leak out into space. So they could be watching the Great British Bake Off or Doctor Who, or all these things that we like to watch these days. But there are loads of planets out there, and we think that there could be lots of aliens, and we also think it's likely. So maybe it won't be too long before we find someone, and perhaps one of you out here could be the first person to grow up, become a scientist, and find the aliens, and that's really exciting. So we'll go back to our question we asked at the start then. Who thinks there are aliens? Give us a chair. Yeah. Give a chair. And who thinks there aren't? Yeah. Still a few are unconvinced, but I think we still think that there are aliens out there, so we've not put you off the idea. So yes, so we think that there could be aliens. We've not found them yet, but maybe one of you could.